It is day 21 in Algebra 2 now. And yesterday we started Unit 3. We're talking about absolute value. So today I gave you 4 problems to try to do on your own, similar to what we did yesterday. And we're just going to run through those. So before we do this, can somebody remind me, what is absolute value? What does that mean? We gave a definition yesterday.
A number's distance from 0.
Yes, exactly. The absolute value just tells us the distance from 0, which again is just a positive number. Distance can't be negative. I can't say I'm negative 5 feet away from Kelsey. I would say I'm 5 feet. It doesn't matter the direction. We're only talking about how many units of space. So, always positive. Because of that, if we have a negative number inside of these bars, these absolute value bars, we have 2 different values that we're looking at. So when we have 2 values and we're thinking about an equation, to solve an equation, we can't just use one equation. We're going to use 2 equations. So before we can solve this, somebody tell me, what are the 2 equations I'm going to use to solve number 1? Yes.
Would one be 8 plus 4x equals 16, and then one would be 8 plus 4c equals -16?
Yes, you got it. Perfect. We're going to keep the same equation, but remove the absolute value bars. 8 plus 4x equals 16. So we have one with a positive answer. And then we're going to do the same thing, but -16. We need a negative answer too. So 8 plus 4x equals -16. So that's the only difference. Remember, the negative is going to go on the number after the equal sign. We're not changing anything inside the absolute value bars. So let's go ahead and solve our positive equation. What would I do first?
Subtract 8 on each side?
Yes, let's subtract 8 on each side. My 8s will cancel. I'll bring down 4x equals 16 minus 8. What will that give me? Positive 8. And
divide by 4.
good, we'll just divide by 4 on each side and get x equals +2. Good, so that's our first answer for x. I know that if I plug x back into this problem, I would do 4 times x, 4 times 2. That's 8 plus 8. That's 16, so it's correct. We know it works. So let's do the negative one now. I have 8 plus 4x equals -16. Will I do anything different here for my first step? Perfect. We're not going to do anything different. It's the same exact problem. We're just going to have a different answer for this subtraction. Instead of getting +8, now I have -16 minus 8. -24. Good. I'll bring down my 4x equals -24.
It'll be -6.
Yes, we'll divide by 4 just like we did in the previous problem. And now I have -24 divided by 4, which is -6. Very good. You got it. So I did write on the directions, draw a number line and graph. So I'm just going to take a sticky note for that part, since I really didn't give you room for it. And we're going to graph our answer. So I will just draw a line going left to right. And which number goes first? -6. We want to put the smaller value first because that's how number lines work. -6, and we'll put a dot on that -6 to show that that is one of our answers. And 2. There we go. So this is the graph of x, -6 and 2. Wonderful. So let's do number 2. It'll be very similar to number 1. What should I do here? What's my first step? Yes.
7 minus 5x equals 17.
Perfect. 7 minus 5x equals 17. There's our positive equation.
7 minus 5x equals -17.
Perfect. Then our negative equation, 7 minus 5x equals -17. We're just changing the answer. Okay, so let's go ahead and solve these. What would I do first? Subtract 7 on each side. So now when I bring this down, don't forget to bring down that minus sign. It's -5x equals 17 minus 7 is positive 10. Good. And last step here, divide by -5.
Your x equals -2.
And x equals -2. Good. So there's our first answer. Let's do our second one. Am I still going to subtract 7 or do I need to do something different? Yeah, you're still going to subtract 7, same as normal. The only thing that changes is the answer. So those cancel. We still bring down -5x equals. Now what's -17 minus 7? -24. Okay. Last step here. Divide by -5.
Your x equals 4.8.
X equals positive 4.8. Perfect. Perfect. And remember, it's because those two negatives cancel out. We get a positive. So let's graph this one. Which number goes first?
-2.
-2. Good. And then my 4.8. Wonderful. Graphing those isn't too bad. Okay. Do we have any questions about number 1 or 2 before we move on to number 3?
It's just simple.
Good, good. Okay, so number 3, we have something a little bit different because, well, I'm not going to tell you. You tell me what's different about number 3. Yes, there is a number on the outside of the absolute value bars. Now, we didn't talk about this in 1 and 2, but the first step is to get the absolute value by itself. In 1 and 2, they were already by themselves. How can I get number 3 to where the absolute value is by itself? How could I do that? What is that 4 doing?
What is the distributed?
Distributed. You would think, yes, you would think maybe I could just take 4 times -2x, 4 times 4. But because of the absolute value bars, that's going to make it a little tricky. This is multiplying, though. How do we get rid of it? How do we get rid of multiplication? Divide. Yes, let's divide first. So before we can split anything up, we have to get the absolute value isolated by itself. So let's divide by 4 on both sides. Okay. Now what happens on this side over here? They cancel. Good. They cancel out. And now we can bring it down. We do finally have the absolute value all by itself. -2x plus 4 in absolute value bars equals, now we just need 88 divided by 4.
Positive 22.
Positive 22. Good. Okay. What should I do from here?
Don't you separate it?
Yes, we're going to separate into two equations now, just like in number 1 and 2. So, whenever I separate into two equations, what will change?
Just the sign on the answer.
Just the sign on the answer. Good. We'll also get rid of the absolute value bars because that could be confusing. So I've got negative 2x plus 4 equals negative 2x plus 4 equals, so we'll have a positive 22, and the other equation will be the same, but with negative 22. So we have our first equation, negative 2x plus 4 equals 22. How can I solve this?
Are we subtracting
Yeah.
4?
Yes,
Four.
we'll subtract 4 from both sides. And those 4s will cancel. Then we'll bring everything down. Negative 2x equals 22 minus 4. Is that 18?
Yes.
I think so. 18.
And then you divide by negative 3.
Perfect. Divide by negative 2.
Your x equals negative 9.
X equals negative 9. Perfect. All right, thank you. Okay, so now let's do the next equation. My first step here.
Subtract 4.
Subtract 4, same as the other. Minus 4, minus 4. Bring everything down. Negative 2x equals,
Negative 26.
good, negative 26. And then
Divide by negative 2.
divide by negative 2.
Your x equals positive 13.
X equals positive 13. Good, those two negatives cancel. Wonderful. And then we'll graph it. Which number goes first?
The negative 9.
Negative 9. Good. And then 13. Wonderful. Okay, that is number 3. Number 4 is a challenge, just because I threw a few extra things in there, but I know y'all can do it. What do I have to do for number 4 before I can start splitting into two equations?
So you have to get rid of the negative 5 first.
We have to get rid of the negative 5
And the positive 6.
and the positive 6. Yes. Does it matter which one I get rid of first?
Yes.
It does matter, because think of it like this. I have negative 5 times something plus 6. So we can almost think of this as a variable in the middle. If I had negative 5x plus 6, I would need to get rid of that plus 6 first, right? So we need to get rid of plus 6 first. How do I do that?
Subtract.
Subtract.
Subtract 6.
Minus 6 on both sides. Okay. Let's see, I'll bring everything down. I still have negative 5 absolute value. 10x minus 4 absolute value equals, what is negative 64 minus 6?
-70.
Negative 70, good. Negative 70. Okay. Now what?
Divide.
Divide by the negative 5. Now we can get rid of that. Okay. And those negative 5s will cancel, so we can bring down our absolute value, 10x minus 4 equals negative 70 divided by negative 5.
+14.
Positive 14. Now, some of you might have thought at the beginning, since there's a negative right here on the outside after the equal sign, that there would be no solution. But because once we got rid of the stuff outside of the absolute value, it became positive, there will be a solution, so we can solve it. What do I do at this step?
Break it up into equations.
Yes, now we just break it up into 2 equations. So I have 10x minus 4 equals positive 14, and same thing, but what changes in the second equation?
Sign.
The sign. 10x minus 4 equals negative 14. Okay, so let's solve the positive. What do I do first?
Add 4 on each side.
Add 4 on each side. And I get 10x equals positive 18. We'll divide by 10 and get x equals
1.8.
1.8. Perfect. Okay, now my negative equation, what's my first step?
4 on each side.
Good, add 4 on each side, same as the last. I'll bring down 10x equals negative 14 plus 4 is negative 10.
And you divide by 10.
Perfect, divide by 10 and we'll get x equals
-1.
negative 1. Perfect, x equals negative 1. Wonderful. And one last graph. Which number comes first?
-1.
Good. Negative 1 and then 1.8. Wonderful. Okay, so that was a really nice job, guys. Really, really nice. We have solved quite a few absolute value equations. Now, this is where we're just finding x, and there's going to be 2 values. But what we're going to talk about today is graphing absolute value. It sounds scary, but I promise it won't be bad. It really won't. So let's go ahead and put this away, and we are going to take some notes. I'm going to show you some things. Oh, do you guys still need to see this? I'll leave it up for a second. I see a few people still copying things down. Let's open a page of notes. And I am going to remove that. Let's title this Algebra 2, Unit 3. And today is day 21, so these will be our day 21 notes. And again, today's date, what is it? Tuesday, September 9th. Thank you, thank you. Tuesday, September 9th. And this is page 1. So we are going to talk about absolute value functions. I'm going to write that here. Absolute value functions. And the first example I would like to give you of an absolute value function is y equals the absolute value of x. So we're going to start by making a table of values. We're going to put an x here and then a y. And let's give ourselves, let's see, 1, 2, 3, 4, 5 spaces underneath. Give ourselves a little table here. So if y is equal to the absolute value of x, what if x is -1? If x is -1, how could I find y? This is what we're going to do. I'm going to use this function. This function can act kind of like a little machine. When I put a number in it, it's going to spit back out a different number based on what I've given you. So my x is 1. We'll plug that in and solve for y. So y is the absolute value of -1. What is the absolute value of -1? 1. So when x is -1, y is 1. So I'll put that right here. X is -1, and that's how we did that. What if x was -2? I know y is the absolute value of x. So what's the absolute value of -2?
2.
2. 2, +2. So now I've got -2, +2. What if x is 0? I know y is the absolute value of x. If x is 0, what is y?
0.
0. It's also 0. The absolute value of 0 is 0. And we'll do 2 more. What if x is +1? I know y is the absolute value of x. And x is 1, so what is y? 1. It's also 1. Do you notice a little bit of a pattern here?
Yes.
Whatever your number is, it's the positive version. If it's already positive, it just stays positive. So tell me, what if x is 2? What will y be?
2.
2. Not so bad. So what we've just come up with is a list of coordinates. We have x values that go with y values. So let's look. Let's make a list of coordinates from this. And y. So my first coordinate would be -1, 1. What would my next coordinate be? -2, 2. And then, good. Yes, perfect. And so on. We could do this with any number we can think of. What we're going to do now is take these values, and I would like for everybody to grab one of these sticky notes. You should have graph sticky notes at your paper or at your tables. If you do not, let me know and I will happily give you one. All of your tables should have sticky note graphs. What we're going to do here is draw a y-axis and an x-axis. And I'm going to label some points. So let's go with 1, 2, 3, 4, 5, 6. And then my x's. Two, 3, 4, 5, 6, and my -1, 2, -3, -4, -6. I'm just going to leave dashes down here. So once you've got a graph drawn, let's put some of these points on the graph and see what happens. My first coordinate, we said, would be -1 for x, 1 for y. So remember the x comes first and the x-axis goes left to right. So I'm going to start here in the middle and I'm going to go to -1 on the x-axis, +1 on the y. So we're going over to the left 1, up 1. And that's our first point. And we can do the same thing for -2, 2. My x is -2. Go over to the left, -2. My y is +2, 1, 2. Where is 0, 0 on the graph? Right in the middle. Good. You don't see 0 on the graph. It's because that's our point of origin. It's right in the middle. And then we'll do our positives, 1, 1, and 2, 2. 1 to the right, up 1, 2 to the right, up 2. Now you can see there's a bit of a shape forming. Using what we just kind of figured out in the table, using this pattern, we could draw more points without even doing any math. I could see that no matter what my x value is, when it's positive, my y value is the same. So what if I went to 3 on the x-axis? How high up would I go on the y?
3.
3. See how it falls in that line still? 3, 3. What if my x was 4? What would my y be? 4. We could keep going. What if my x was -5? It'd be +5 for y. Right. This is the graph of y equals absolute value of x. What we need to do now is connect the dots, and we'll see we've got a nice V shape. Yes, you should have a nice V shape. Just like that. So there is our absolute value graph. Now, thinking about the numbers on the graph, where these points are falling, can any of you make an educated guess why it's making this shape? Why do you think none of our points are below 0?
Because absolute value can be negative.
That's right. Absolute value cannot be negative. So your y will always be positive as long as there's no negative on the outside. Right now, we just have absolute value of x is y. It doesn't matter what x is. Your y will always be positive. It will always go up in this line. So using that information, let's think about second problem. Can I move this? Okay, I'll wait just a minute. You're fine. Let me pause this. So I'm going to go ahead and get an x and a y axis ready. So I'm going to use it again. And I won't worry as much about labeling all of my numbers so that we can have a little more time on this. What if now I gave you y equals the absolute value of x plus 3? That's my function. Let's make a table. I have x and y. Let's come up with a number for x. It can be any number, but let's try to pick a small number. Somebody give me a number, any number.
2.
2. Okay. So if x is 2, what would y be?
2.
Let's see. I know that y, I'm going to do this on a sticky note. I know y equals the absolute value of x plus 3. And what is my x? We picked 2, right?
Oh, 2.
That's okay.
I'm sitting there
2.
looking at it going,
You're all
I'm
right.
putting one finger.
So we know that x is 2. I'll put this. So y won't be 2 this time because now we have a plus 3 at the end. Let's see. I know, now it's trickier. So first, let's get rid of the absolute value bars. What is the absolute value of 2?
-2.
Is absolute value negative?
Oh, no, it's never can be.
It never can be. So what is it? It's just 2. The absolute value of 2 is 2. So I'm got rid of that. And let's bring everything down. Y equals 2 plus 3. What's 2 plus 3? 5. So y equals 5. Ah. So when x is 2, y is 5. What about when x is 1? How could I figure out my y? Hmm.
4.
How do you know it's going to be 4?
Because you take the absolute value of
Yes.
1,
Mm-hmm.
which is 1, plus 3.
Yes, 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 yes. So we're using the same function, y equals the absolute value of x plus 3. If x is 1, well, the absolute value of 1 is just 1 plus 3. And 1 plus 3 is 4. So when x is 1, y is 4.
Subtract 1 from our first answer because it's 1 lower.
You can do it that way. That's a good way to do it.
It's easy to find some rewriting the problem.
Right. It absolutely can be. What about when x is 0? When x is 0, I'm still using the absolute value of x plus 3. Y equals the absolute value of x plus 3. What is x? 0. So y equals, what's the absolute value of 0?
0.
It's 0 plus 3. What is y? 3. Uh-huh. So y is 3. So how about now we use the same numbers, 1 and 2, but we make them negative? What about negative 1? Y equals the absolute value of x plus 3. So I'm choosing negative 1 for my x. I'll put that in for x. What is the absolute value of negative 1? 1. So 1 plus 3. Y equals
4.
4. Okay. You're going to notice a pattern here as well. Positive 1 for x, my y is 4. Negative 1 for x, my y is 4. My y is my answer. It's always going to be positive in problems like this. So if I gave you x is negative 2, what do you think my y is going to be?
5.
5. How do you know it's 5? How do you know?
When you connect -2 plus 3, I forgot what you call the number one.
Absolute value.
Yeah. The absolute value of -2 is 2, the 2 plus 3 is 5.
Perfect. Perfect. Because whenever I put a negative number in absolute value bars, it's going to become positive anyway. So this becomes y equals 2 plus 3. And 2 plus 3 is 5. So once you have a positive answer, I know my positive x was 2, my y is 5. My negative x is 2, or negative 2. My y is still going to be positive 5. Let's look at what this graph will look like. I'm going to move these out of the way. Stick them over here. So my first point is 2, 5. So I'll go over 2 on the x-axis, up 1, 2, 3, 4, 5 on the y. 1, 2, 3, 4, 5. What's my next point? I just did 2, 5.
1, 4.
Let's do 1, 4. So over 1, up 4. What's the next point? 0 for x. 3 up for y. Good. Good. Okay. Next point, I have negative 1, 4. So now we're going to go to the negatives on the x-axis. So negative 1, I go over 1 to the left and up 1, 2, 3, 4. We have one right here. And finally, negative 2, 5. Over 2 to the left, up 5. There you go. And it made that nice V shape again. So we'll connect our points. And that's our graph for y equals the absolute value of x plus 3. There you go. So the only thing that was different between the first graph and the second graph is our starting point. It looks like we have the same graph, but it shifted up 3 spaces. You see that? It started here in the first one, but we went up 3. And that's because in the first problem, our x is equal to the, or sorry, our y is equal to the absolute value of x. So those numbers are going to be the same starting at 0. Whenever we have the absolute value of x plus something, 0 is no longer the starting point because when x is 0, y is going to be 3 more. So that's why we're starting up at y is 3. So interesting stuff to think about. I'll leave this up for a minute and then we'll do a little more practice before I point some things out to you. I'll pause this and let you guys catch up your writing. Okay, so Kelsey made a really good suggestion. We could label our points. So I'll label 2, 5 as A, 1, 4, B, O, 3, C, D, E. Great suggestion. So we can label the points on our graph. 2, 5 was here, so that's A. 1, 4 is B. 0, 3 was C. Negative 1, 4 was D. And negative 2, 5 was E. Yeah, very good suggestion. It's never a bad idea to label your graph. Yes.
Can you use another sticky note and graph it again?
Yes.
I totally wrong.
Yes, I can. I absolutely can. How about this? Let me zoom in a little. And let's do it again. Kind of like whenever we label the line with the colors. I think that helped a little. 1, 2, 3, 4, 5, 6, negative 1, negative 2, negative 4, negative 5. So I'll start. 2, 5 is A. 1, 4 is B. 0, 3 is C. -1, 4 is D. And -2, 5 E. And I connect my dots. Is that a little easier to see? Okay, good. Good. This is y equals the absolute value of x plus 3. There we go. Go. I'll pause that for a minute. Okay, so we have a few examples here, and now let's look at our worksheet that I just gave all of you. And I am going to write on here at the top, day 21. Just so that I don't lose track of what day we did this. And let's look at some of these examples. What I would like you to do, I'm going to switch to a pencil now so that I can write a little smaller, is before we graph these, because I know graphing can take a little bit of time, let's work on making these tables so that we can find values. My function is y equals the absolute value of x plus 3. So x, y. We are going to start with x as 0. How would I find my y value? What would I do? I have an equation. I don't know y, but I do know x. Yes.
You plug it in?
Plug it in. So let's do the absolute value of 0 plus 3. So honestly, let's put it right here. 0 plus 3. What is the absolute value of 0 plus 3? It's going to be 3. 0 plus 3 is 3. The absolute value of 3 is 3. What about when x is 1? What would my y be?
4.
It's going to be 4 because look, we have x is 1, but it's x plus 3. So I'm going to do whatever my x is plus 3. 1 plus 3 is 4, and the absolute value of that is 4. Okay. What about when x is 2?
So the value of 3, 2 plus 3
Yes.
equals 5.
Good. So I'm going to put here absolute value bar, plug in 2 for x. 2 plus 3. 2 plus 3 is what? 5. The absolute value of 5 is 5. What about -1? Well, now this time it could be different. I have absolute value of -1 plus 3. What is -1 plus 3?
2.
It's 2. What's the absolute value of 2?
2.
It's 2. Now this is different than that last one, where you remember whenever we did this one right here, we would get, let's see, my +1 for x, my y was 4. My -1 for x, my y was 4. The reason that our positives and negatives have the same y value is because we didn't do anything to x inside the absolute value bars. That was on the outside. Since there's stuff happening inside, our y's are going to change a little. We'll see what that does to our graph here in a minute. Let's also do -2. So now I have -2 plus 3 in absolute value bars. What's -2 plus 3?
1.
1. What's the absolute value of 1? It's 1. Okay, now this is not the neatest way to write this. I don't love how that chart turned out. So I'm going to rewrite it over here. I got 0 and 3, 1 and 4, 2 and 5, -1 and 2, -2 and 1. So let's put that on a graph. Let's see what happens. Let's see. Make this go a little further down. Now, I have this time brought my graph, I haven't drawn my y-axis as low. The reason for that is because notice all our y values are positive here. I don't really need my negative part of my y, because my y-axis above is positive numbers, 1, 2, 3, 4, 5, 6, 7. And my x's are over here and over there, left and right. So I'm going to label my points A, B, C, D, E, and I'm going to put them on my graph. My point A was 0, 3. So I'll go over 0 and up 1, 2, 3. And that's A. And 4 for B. I'll go over 1 up 4 for B. C, I have over 2 up 5. Point D, I've got -1 for X, up 2. And then point E, I have -2 up 1. We don't have a V shape on this one, do we? What do you think that means? Hell yeah. Anytime we do absolute value, you'll always have a V shape. Always. If you don't have a V shape, then we need more points. That's what needs to happen. So I know that -2 for my x, I kept going, and this couldn't have been my very lowest point. We kept going down. So why don't we try one further out and see if it gives us a point that goes up higher? So how about we try -4 for x? X is -4. How could I solve for y? What could I do? What did I do to find all my other y values? We plug them in to this function, right? To this equation. So I know y equals the absolute value of x plus 3. If x is -4, let's find y. Let's plug it in. Y equals absolute value. Here's my x. -4 plus 3. It will work. You might think it won't. Let's see. What is -4 plus 3? You said it's -1? So watch this. This is y equals the absolute value of -1. What's the absolute value of -1? 1. So it's 1. So when x is -4, y is 1. So we're going up higher. If you notice on an absolute value graph, you always have a lowest point, a vertex. So these two can't be my lowest points. I have one single lowest point. If I'm connecting these dots, wouldn't it make sense that this would be my vertex? And this is where it turns around. We see that? Oh, there's the V shape. There it is. Always a V shape. Always a V shape. Okay. Very interesting stuff. It is pretty amazing. Let's see. So there's that one. I'm going to move this down here if this is okay, so that I can see number 2. I've got 2 operations. Oh my goodness.
Stepping it up.
Stepping it up. So let me show you something that's going to make this a little bit easier. Because this is a long process, isn't it? Long process. There's a way to make this more simple. So before we continue on problems, I would like for us to pull out our notes again, and I want to give you a few things that we can write down. I'm going to start a second page of notes here. Algebra 2, Unit 3, Day 21 notes. Continued. And this is page 2. We know that y equals the absolute value of x is going to always create that graph where, and let's just do it like this real quick. I'm going to make a little baby graph right next to it. We're always going to start at 0 because when x is 0, the absolute value of that, y is 0. So this is our middle point. Then we know that when x is 1, y is 1, x is 2, y is 2, x is 3, y is 3, and so on. X is -1, y is still +1. X is -2, y is still +2. And that's where we get this V shape. So this is what we call our parent function. It's the original equation. Now, if I have y equals x plus or minus, we'll call this h. Whenever I add or subtract a number inside of the absolute value, there is a shift that happens in my graph. You'll notice on this problem, we had y is the absolute value of x plus 3. This is the same graph as the original, except now our vertex scooted over 1, 2, 3 spaces to the left. So here's what happens. When I add h, I am moving h spaces to the left. So you're going to move h spaces to the left. If I subtract h, so if there's a minus sign, we're going to move h spaces to the right. It does the opposite of what you think it would do. So I'm making you a key right here. So here's whenever we have plus or minus something on the inside. So when it's inside, we shift to the left or right. Now, if I have something added or subtracted on the outside, something different happens. Y equals, we'll say the absolute value of x plus or minus k. So this time, it's outside the absolute value bars. When we're outside the absolute value bars, just like in this example, we had plus 3, we just moved the same graph up 3 places. Notice how instead of it starting at 0, it starts up 1, 2, 3. So whenever we have plus k on the outside, we shift k spaces up, k being whatever that number is. What do you think will happen when it's minus k?
Spaces down.
Yes, we will shift however many spaces down. Perfect. So our original function is y equals absolute value of x. When you add or subtract inside, you move to the left or the right. When you add or subtract outside, you move up or down. So let me show you some examples. I'll leave this up though and let you guys finish writing, and then we'll move forward. So while you're finishing up writing that, let's look at number 3. I have y equals the absolute value of x minus 3. Is that minus 3 on the inside or the outside?
Outside.
On number 3, inside or outside? One more time.
Outside.
Outside. So, outside, am I going to shift up or down?
Is it down?
Down, because it's minus 3. Minus k, shift k spaces down. Minus 3, we'll shift 3 spaces down. So for this problem, we have, let's see, give me 1 second, Greg. Let me find my sticky note that has the original one on it. I might just have to make a new one. We said for number 3, we have y equals the absolute value of x minus 3. So instead of starting at 0, 0, how many spaces did it say we shift? 3 down. So I'll go down 1, 2, 3. Now this is my starting point. And from there, we can create the V. We know it's going to go up 1, over 1, up 1 over 1, up 1 over 1. Same this way. How much easier is that? A lot easier. Once you learn the rules, you don't have to do so much work. You're done. That's not too bad. We'll do more practice. We'll do more. Okay, let me pause for a second. All right. Now, the one thing to notice though is as long as we're not multiplying anything, we're going to ignore any problems with multiplication today. We're just going to focus on the add and subtract. That's it. You're going to do the same V shape. It's just going to be starting at a different spot depending on the number. So I'm going to put this over here. What about on your worksheet, number 7? Number 7 says y equals the absolute value of x minus 4. Do we have a shift on the inside or the outside? Inside. It's minus 4. What does it say to do when we minus on the inside?
To the right.
Move to the right. So minus 4, we're going to move to the right 4. Remembering that 0 is the starting point. So I'll draw a little graph. And I'll touch 0. So I'm going to go over 1, 2, 3, 4. This is my new starting point. All I have to do from here is draw my V shape. Over 1, up 1. Over 2, up 2. Over 3, up 3. Other way. And then connect your dots. See that? We went over 1, 2, 3, 4. See that? Okay. Are you guys ready for a little break? It's 2:16. Normally we stop about 15 minutes ago. 2:17 now. Let's just say we'll take a little break, come back about 2:30. About 2:30. And we will do some more practice with this, and I'll let you guys try some of these on your own, and I'll be around to help. So I'm going to pause it there, take a break. We'll be back. So let's use this graphing paper to make the next part a little bit quicker. And Angel, I'm going to give you one of these, or they're on the wooden table of graph paper. So, and if you want, so that you have this before I move it, do you want to take a picture of that so that you'll know what we're talking about? Perfect. Okay, so let's move to that worksheet again, the one that says graphing absolute value. And let's look at number 8. Let's look at number 8. And I'm going to copy that problem down right here for number 1. I have y equals the absolute value of x minus 4. Okay. So I know my parent function is y equals the absolute value of x. The extra thing we have added on is the minus 4. Now, is that minus 4 inside the absolute value or is it outside?
Outside.
It's outside. So let's look at the outside options. If it's plus a number, we'll shift up. If it's minus a number, we'll shift down. What are we going to do here? We're going to shift down. So let's write here. I'm going to write as a reminder to myself, minus 4 outside shift down 4. So remember, our starting point is always that 0, 0. But since we're going to shift down 4, what will our new starting point be?
-4.
-4 on the y-axis. So I'm going down 1, 2, 3, 4. Here's my starting point. Now that I know my starting point, I know that absolute value functions create a V shape. And that V shape, we do have to be careful that we're not just drawing a random V because that won't match. Make sure that we're looking at the units. We'll go over 1 to the right, up 1. Over another 1, up 1. And once we have 3 points this way, that's good enough. Then we'll go back to the origin point, over 1 to the left, up 1. Over left again, up 1 more. And there it is. We'll connect our dots, and our graph is done. Oh. For the next one, let me zoom out a little. I'm just going to kind of demonstrate a few to give us kind of a good key here. Let's try, I'm going to give you a random one, not from that worksheet. It could be on there, but I don't know for sure. Y equals the absolute value of x plus 2. Is the shift on the inside of the absolute value or on the outside? Outside. And let's underline what we're talking about. Plus 2 on the outside. So let's write that. Plus 2 outside. So when it's plus something on the outside, where will we shift? Up 2. Good. So we'll shift up 2. So again, our original point is at 0, 0. Where will my new point be? Up 2 spaces on the y-axis. Good. So this is my new first point. And I know my absolute value equations make a V shape. So we're going to do the same thing we did over here. Over 1, up 1. Over 1, up 1. Back to the center. Over 1, up 1 in the negative direction. Over 1, up 1 in the negative. Oh my goodness, I can't speak, y'all. Negative direction again. And then we'll connect our dots. What we did is we just shifted up 2 and we drew the same graph. We'll give you y equals I'm going to look at number 7 on my worksheet, which is the absolute value of x minus 4. How is this one different from number 1? It's on the inside now. Number 1, our shift was on the outside, minus 4, down 4. Now it's on the inside. When our shift is on the inside, you're going to do the opposite of what you think you'll do. So we'll look at our key. We know it's minus 4 inside. So on the inside, when we subtract a number, what do? We move to the right. Good. So since it is minus 4 inside, we're going to move to the right 4. So instead of starting at 0, 0, where will we start?
Positive 4 on the X line.
Yes, positive 4 on the X. So I'm going to move over 1, 2, 3, 4. And this is my starting point. So my starting point is 4, 0. What is another point on this graph?
5, 1.
5, 1. Over 1, up 1. Good. What's another point?
6, 2.
6, 2. That's over 1 more, up 1 more. Good. So we have one side. I need 2 more points. What's another point to the left of this? I want it to create that V shape. What's another point?
Is it over 1,
Over 1, up 1.
Over 1, up 1. And we've done 2 to the right. Which way should I do over 1 this time?
to the left?
To the left. So over to the left, 1, up 1. So there's a point at 3, 1. I can go over 1, up 1 one more time at 2, 2. And then I'll connect my dots. So you're making the same shape every time. Once you get really used to drawing that V shape, the hardest part is just knowing which way to move your origin point. And we'll do one more. Y equals absolute value of x plus 3. What kind of shift will I do here?
Uh,
Let's see. Is it inside or outside?
inside.
It's inside. So whenever it's on the inside,
Oh, it's left or right?
left or right. On the inside, we have plus 3.
We go to the left.
So plus 3. Move 3 to the left. So I have plus 3 inside. So I'm going to shift 3 to the left. So instead of starting at 0, 0, Where will I start?
Negative
-3.
3.
Good. 1, 2, 3. Okay, let's put some points on here. From -3 on the x-axis, where do I go for another point?
Negative, go over 1, up 1.
Yes,
Negative.
-4, up 1. Good. What's another point?
Up 2.
Yep.
-5, up 2.
Yep. -5, up 2. So I've got my 2 points to the left.
-2 up 1.
-2 up 1. Perfect.
-1 up.
Yeah. Oh, almost.
No.
-1 up
Up 2.
2. Good. So
Yeah.
it makes that V shape. Nice, guys. Nice. Okay, and we'll just connect those. Thinking of these as shifts, does that help? I think it does. It helps me. It's just a lot less work. Because once you figure out the tricks and they start to become easier to recognize, it's a lot easier to do it. A lot easier. Okay. Okay. What if we have something like number 2 on this worksheet? There's 2 things happening. Y equals absolute value of x minus 1. We'll close the absolute value bars. And then plus 2. This. Yes, we have 2 on the outside. So let's go ahead and say what this will do. Plus 2 on the outside. Yes, this is going to cause us to shift up 2 spaces. So we're going to go up 2. But is that the only shift we have? There's another one. What's the other one? -1. So we have -1. Is that on the outside or on the inside? Inside. So we also have -1 inside. What kind of shift do we do when we subtract inside? Yes. So we're on the inside and we have a minus. So we're going to go to the right. Good. So -1 inside will go to the right one. So here is my starting point.
Okay, so that's basically like giving you that starting point.
Yes.
Coordinate.
Yeah, it's like this is the vertex.
Yeah.
The vertex of y equals absolute value of x. But now we're going to add 2 and we're going to subtract 1. So let's do 2 shifts. Let's look at our outside first. We have plus 2 outside, so we know we're going to shift up 2. So I'm going to go up 1, up 2, and then -1 inside. We said we would move to the right one. So we'll move right 1. And now this is our vertex at x is 1, y is 2. Let's put some more points on this graph. What is another point on this graph?
2, 3.
2, 3? Yes, perfect. That's just over 1, up 1. What's another point?
3, 4.
3, 4. Good. Over 3, up 4. 1/2 is done. Okay, I need 2 more points.
Over 1, up 1.
Over 1, up 1. Oh, from here?
Yeah,
Okay, over 1 to the left or right?
left.
Left, and then
Up
up
2.
1.
Wait a minute, hold on. Maybe my point ain't right, hold on.
Is your vertex, your point, we started at 0, we went up 2, we went over 1. So it should be at 1, 2.
Yeah, I did so.
Yes.
So.
But you were right that we're going to shift.
Is it shift to the left 1 and up 1?
Yes. So over 1, up 1. We've got a point at 0, 3. Well, these graphs are kind of small. They're a little tough to read. We'll just go over 1, up 1 again. We're always making that V shape when we're just adding and subtracting. Oh, okay, now I want you guys to try one on your own. Y equals, let's do absolute value of x minus 3, and then another plus 2. So look at that little key we made. Decide if your shifts are inside or outside, and decide which way to move the vertex. So I'll pause this, and I'm going to see if we can figure it out. What should I do? Somebody tell me, what is your thought process when trying to graph this? Go ahead, Kels.
So I take note that +2 is outside. I know that I'll need to go up on the graph
Plus 2
from 0.
up. Okay, so we're going to go up 2.
And then the -3 is on the inside, meaning I will have to go to the right.
Okay, to the right, 3. 1, 2, 3. So what is my vertex?
3, 2.
3, 2. Here's a neat trick in the future. Your vertex is this number for x reversed, since it's -3, +3. Whatever's added on the outside is your y. That will always work every time. This is your vertex. Okay, so what are some other points?
My next point was 4, 3.
Okay, 4, 3. Okay.
5, 4.
5, 4, perfect. So there's one side.
And then on the left, I have 2, 3,
2, 3.
and 1, 4.
Perfect. And then 1, 4. So you'll always want 5 points. You'll want a vertex and then 2 sets of points on opposite sides. Now, something you might notice, this is really similar to a parabola. There is also an axis of symmetry. These graphs can be cut in half. Once you find one side of your points, you can also just say, well, it's one away from there. Let's do the other side, make it equal. You can split them up like that. So if your graph is not symmetrical, you know you did something wrong and you'll want to go back and check it. But you're going to want 5 points every time. Okay. Can we do an exit ticket? You guys think you can? How did you guys do on this one on your own? Did we do good?
Yes.
Yeah.
Did we go okay? Little bit. Hey, we're learning. We're learning. That's good.
Yeah.
Okay. I have an exit ticket for you. It is 304. And that exit ticket looks like this. I'll make copies. I want you to graph this function and label 5 coordinates, just like we did here. Okay, so let me leave this up in case any of you are wanting to do kind of a rough draft while you're waiting, but I am going to run some copies and I will be right back. But that is all today. The end.